I love water. Oh, hey, what's going on, guys? I just wanted to give you and myself, because I love to play with water, a little bit of introduction to water and what makes it so special, right? What is this whole polarity thing that everybody keeps talking about? I know it's the hip, cool thing to do, is to talk about how polar someone is. And even if it's not, it's going to be. You heard it here first. Being polar is something that's going to be really cool the next few years. Anyways, what I've drawn here is a molecule of water, right? And when we talk about water, we need to talk about polarity. Polarity means that there is an uneven distribution of electrons. So you look at this picture, each dot here represents an electron. So most of the electrons are not here, right? They're on this oxygen. So more electrons, remember electrons are negatively charged. So more electrons means more negative charge. So we're going to say that this side is more negative, right, than this side, which would be more positive. If you compare the two, right, you compare the charge here and the charge here, this is more negative than this. So we have a negative charge here and a positive charge here. You follow me so far? Good. Say do this water molecule here. This has a positive, this has a negative, and this has a positive down here. Again, because the electrons, there's so many of them up here compared to what there are down here. All right? Makes sense so far? So we got positive and negative charges. That's what makes something polar. If the electrons were evenly distributed here, this would be nonpolar. Okay? But because there's uneven distribution, that makes it polar. So we look here, we have a negative here and a positive here. Well, things that are negative and positive, they attract each other, right? They like each other. Okay? So we have a bond, right? We have an attraction between this hydrogen and this oxygen. That is known as a hydrogen bond. Hydrogen bond is between the oxygen of one molecule and the hydrogen of another. So what we get here is a hydrogen bond, and that allows water to do some really cool things. Okay? Hydrogen bonding is what allows water to stick to itself. It's what allows it to stick to other things. We're going to show you a little bit about what water can do because of this hydrogen bonding. Again, it all has to do with polarity. If these molecules aren't polar, no hydrogen bonding. But because we have polarity here, right, we have a negative charge and a positive charge, there's that attraction. And that's that hydrogen bonding that makes water do some really cool things. Let's take a look at that real quick, okay? I know I sprayed some water around here somewhere, but whoa! Oh, oh, cut, cut, cut. All right, so two things I learned here. First off, water is really cool. Second, water is really slippery. Yeah, so we'll be a little bit more careful next time. But I wanted to show you a few things that water can do. Remember, we talked about water has the ability to hydrogen bond because it is polar, right? Polar meaning that it has an unequal distribution of electrons. So that means that water has a tendency to be able to stick to itself. I want you to watch the penny here. And I want you to see how many water droplets I can get on this penny without them falling off. But look at the penny right now. Okay, look at the water. Look at the water on the penny. Do you notice something? Do you notice how it like rises above the penny? It doesn't just like fall over. Isn't that cool? I could just keep adding droplets of water. But see how that water just rises above the penny there? Isn't that cool? I know I'm kind of a dork about this, but that's because of hydrogen bonding. The water sticks to itself. Okay, the water has weak bonds between each of the molecules, and that's what allows that to be able to kind of stick to itself. So you can see here, just keep adding more and more water. All right, you can see the water really starting to like come over the top of this. All right, eventually if we add enough water though, the water will fall off because the weight of the water is stronger than the hydrogen bonds that are present. But you can see we got a lot of, look at how much water we got on that one penny. That's pretty cool, isn't it? Eventually, though, yeah, it falls over, all right? But still, that shows you hydrogen bonding. One other thing we can look at is what's called a meniscus, and I think we've talked a little bit about this before. I'm sure you've used them before, graduated cylinders before when you've been measuring things in science class. But you see the little dip right here? You see the little dip of water, how it just kind of goes down? All right, that is the meniscus. That is because of the hydrogen bonding that's present. Water, because the hydrogen bonding actually sticks to the sides. That's called adhesion. Cohesion is what we saw with the penny, where it sticks to itself, but the adhesion to the sides of the beaker, or I'm sorry, to the sides of the graduated cylinder, it kind of creeps up a little bit along the sides. So as a result, we get this little dip here. That's called the meniscus. So I just want to show you some hydrogen bonding, some ways that polarity has an impact on water. So water is able to really stick to itself, all right? You know, when you get like puddles of water and things like that, because of hydrogen bonding, it has the ability to stick to itself, essentially. All right. So, any questions on this? You should be good with this. All right. So, hydrogen bonding, it's cool, it's neat, and there's all kinds of really cool things you can do with water like this. All right. So, if you have any questions, let me know. Otherwise, have a good day.